Okay, grade 12. Today we're going to look at multiple choice questions based on the topic vertical projectile motion. So the first question reads here, a stone is dropped, right? It's dropped. So what information do we get from that? Our VI is equivalent to 0 meters per second from the edge of a cliff. Then which one of the following graph best represents the change in kinetic energy of the same stone during its fall? So here, the key takeaway is that the stone is dropped, so it starts from rest. So our initial kinetic energy is going to be 0, right? So I can say EK initial is equivalent to 0, like that, right? Then after that, as it falls under gravity, its speed increases. Hence, we know that according to definition of acceleration, we're going to say acceleration is the rate of change of velocity, like that. Okay, so it means for me to make a velocity the subject of the formula, I'm going to have something like a v is equivalent to a delta t, right? So now if we're having something like that, now to proceed to say our kinetic energy, so our EK is equivalent to half mv squared. So according to this now, we're going to break it down further and say half is equivalent to half m, then the v now we know it equates to a delta t. So I can say bracket there, a delta t, right? Then I'm supposed to square everything. Then I'm going to proceed again to say maybe expand it there. What am I going to have there? I'm going to have a squared and also what delta t squared, right? So now from this we can see that so the EK versus time graph must have the following, right? So it should start from 0. Okay, for example, A there starts from 0, C starts from 0, but D and B, they do not start from 0. Then after that, the other information is that it increases continuously. Then lastly, it should curve upwards, right? So if it curves upwards, it means our option A is the correct answer. Then moving on to question 2 reads the question 2 reads, a stone is thrown vertically upwards, right? So you just know that when you throw something, it means the initial velocity is greater than 0, then vertically upwards and returns to the thrower's hand, right? So it left your hand and then returns to the thrower's hands after a while. Then which one of the following position versus time graph best represents the motion of the stone, right? So we know you threw it upwards, then it returned back to your head. So according to this, we know that as the object moves upwards, the displacement, the change in position increases, right? So that's number one. So your delta y should increase there, right? Then after that now, what happens as it moves down? It means it slows down. As it moves up, it slows down. And then our slope should also what? Decrease, right? So it should actually be less steep. Then at the highest point, your slope should be 0. For example, there, your slope is what is 0 at the highest point or at the maximum height. Then it comes down, the position time graph is to come down as the position what it decreases, right? Then after that, the graph must always give us a parabolic curve opening way downwards, right? So if we are to look at this, if it's to return to the thrower's end, we can see this is started from a certain position, went up until it got to the maximum height there, and then returns to the same position, making C the correct option there. B is incorrect as well as D is incorrect. The reason why A is incorrect is because there it leaves the thrower's end, then it means here you are a certain height above the ground. Therefore, here we were supposed to catch it at that point there, right? So that it returns to the thrower's end. But unfortunately, it falls way downwards. So that's why makes option A incorrect there. Then we proceed to question number 3. So question number 3 reads here, a person dives from a high platform into a pool. At which one of the following positions A, B, C, or D will the magnitude of the momentum be maximum, right? So we're looking for momentum where it's going to be maximum like that, right? So according to this, we're having A, B, C. I assume this was supposed to be option D, right? So what we can derive from this is that by maybe writing down the formula for momentum, which is P is equivalent to mv, like that, right? So what we should know also is that the mass is constant. So the mass is constant, right? Our mass is going to remain at the same. It's going to be constant. Then after that, momentum, we should also know that momentum is maximum when the speed is a maximum, right? So look at that V there. So if you are having maximum velocity, it means now we are going to have a greater value for what? For momentum there, which is the magnitude for momentum, right? Then the speed is greatest just before the individual hits the water, right? So it means here, this is where the speed is what is maximum. So it means now, according to this, our option there at point A, that's where we are going to have a maximum value or of what the highest magnitude of what of momentum there. So it means it's going to be what our option A. So the least that we're going to have there maybe is at maximum height there where you're going to have a 0 because here you know it makes height there. What are you going to have there? Your V is equivalent to 0 meters per second there, right? Then proceeding to question number 4. Question 4 reads here, a stone is thrown vertically upwards, so you throw it upwards and return to the thrower's hand after a while. Then which one? So the other important key there, it returns to the thrower's hand. So which one of the following velocity time graph best represents the motion of the stone? So we're focusing on the motion of the stone. So now you should also know that the initial velocity is positive, right? According to this is positive. We are going upwards. The initial velocity, we're going to say what is positive, right? So it's positive upwards. Then after that, I'm going to say if we're considering up as being positive there. So then after that, now what you're going to say here, oh, let me just not consider direction there, but I can say that the velocity initial velocity is positive, right? Then after that, we're going to say our velocity is going to decrease linearly due to constant acceleration due to what? To gravity. Then at maximum height there, we know that velocity is going to be what is 0. So we're looking at that point there, assuming this is our maximum height there, it means there is going to be what to be 0. So because this object has been thrown what upwards, right? So we know why is it heading towards a 0 there? It's because as this object goes up there, right, what happens to the velocity? The velocity decreases until it gets to a maximum height where your velocity is going to be what? To be 0. So I can say this is the max height, and also this one refers to our max height, and then the same applies there is our maximum what height, and then the velocity we know here is going to be what? To be 0, like that, right? Then to proceed there, another information that we need to know is that the velocity becomes negative whenever we're going where? Downwards, right? So it means we are supposed to return to the thrower's hand, right? So if we're to return to the thrower's hand, now we're going to have a negative velocity. So now we're going to say a straight line with a negative slope crossing a 0. So that's what we're looking for. We're looking for a straight line with a negative slope crossing 0. So the one that fits that criteria is going to be option B, right? So it means here for option C, what happened there is that you threw this object until the maximum height. So that's where the ball what ended, or the object ended up. Then to proceed, question 5. Question 5 is here. An object projected vertically upwards reaches the maximum height and returns to its original point of what? Of projection, ignoring the effects of friction. The direction of the acceleration of the object during its motion is okay. So we need to know that the force that is going to be acting there on the object is the force of gravity. And then gravity always acts where? It downwards, right? So our gravity always acts downwards like that. Then even when the object is moving upwards, also take note that our gravity is always going to move where? Downwards there. Then acceleration is vertically downwards, right? So it means here what you're going to have, our option A is there always vertically downwards, which is our correct answer. Then moving on to question 6 there. What we're having, it says a ball is released from rest from a certain height above the ground, above the floor, and bounces off the floor a number of times. The position time graph below represents the motion of the bouncing ball from the instant it is released from rest, right? Okay, so we released from a certain height above the ground, then we know here it means here this point here A, this point C here, that's where we're having what our bounce is there. So here it hits the ground there at A and C, this object is hitting the ground, right? Then here B is also our max height, as well as D is our max height, depending from which point are we going to refer after how many bounces, right? So now the question proceeds to say, okay, I can just like consider this one as the first max, and then this one is the second max, right? So this one I will consider it as the first bounce. This is the first bounce there, and then this one is going to be our second bounce. Then after that, it is here neglecting air resistance. Which point A, B, C, or D on the graph represents the position time coordinates of the maximum height reached by the ball after the second bounce, right? So we know this is the first bounce there, it hits the ground and then goes to its first maximum, which is a point B there. Then it moves back to the starting position there, which is your ground or to the ground, and then it hits the bounce to the ground. So this is our second bounce. Then it goes up to a maximum point D. So it means now our option is going to be D there. This is our maximum height after the second bounce. Then moving on to question number 7 reads, a ball is released from rest. A ball is released from rest from a certain height above the ground and bounces off the floor a number of times. Then ignore the effects of air resistance. Then which one of the following velocity time graph best represents the motion of the graph, right? So according to this, we know our velocity increases going way downwards. Velocity increases downwards linearly, right? Then there should be a sudden change in direction at the bounce, right? So what does that mean? It means we're going to have a sharp jump in the what in the graph, right? Then after that, now the other thing we need to know is that this should be, or this pattern should repeat with smaller what magnitude, right? So we can see here velocity increases linearly, so it means you are released from here, then our velocity increases, right? Then like that. So until there you can see it increases then linearly with smaller what or smaller magnitude in terms of what of changes, right? So this makes our option is C more of what of a correct one, right? So if you look at option B, this is more of like a position time graph. This is more of a position time graph. Then this one is more of a wave of some sort, and then option D is also incorrect. So our only correct option there is going to be correct option what A, right? So we know what happens there. If you release a ball from a certain height above the ground, what happens to this velocity? This velocity increases, right? So it increased here from 0 until a certain velocity there, right? Then after that, there is a bounce, right? So after that bounce there, it means it goes again to start up from that certain height above the ground, which is the maximum height. Then it goes again there like that. So it goes to a certain height and then again it goes just like that. So this is the pattern that you're supposed to have. So take note whenever you're asked to draw this in terms of this of the bouncing ball, your lines should always be what? Be parallel there. Then we're moving on to question 8, which is a 30 kg iron sphere and a 10 kg aluminum sphere with the same diameter fall freely from the roof of a tall building. Ignore the effects of friction. When spheres are 5 meters above the ground, they have the same. So what is it that does not change? So according to this, we have got our momentum. Remember, P is equivalent to mv there. So already we're having different masses. So it means they when spheres are 5 meters above the ground, they have the same. So you can see the masses are different. It means we're going to have different momentums. Then acceleration due to gravity remains what? Constant there. It will stay the same, right? Then after that, also we're having this kinetic energy, which is EK is equivalent to half mv squared, right? So the mass there, different masses. Again, here we're going to say EP is equivalent to mgh. Again, the m there we're having different masses. So it means option 8, our answer there is B, because in free fall, all objects have the same what acceleration, right? So if you can look at momentum, kinetic energy, and potential energy, they depend on the mass. So the only one that is remains the same there is going to be our acceleration. Then moving on to question number 9, we're given the velocity time graph below represents the motion of an object. So we're given motion of an object, right? So which one of the following graph represents the corresponding acceleration time graph of the motion for the motion of this object, right? So we're having option A, B like that, right? So now if we can look there, we're looking for the acceleration time graph, right? So if we can look there, we need an acceleration that is constant like that. So it means here, according to this here, I'm going to say positive 9,8. Therefore, it means going down here is considered as positive, and then you can see here I can also say negative 9,8 there. So it means here, where are we going? We're going to say downwards as what is positive. So I will go for both these options, the C or D, depending on the direction of what of motion chosen as being positive, right? Then question 10 there, it says here, a ball is thrown vertically upwards. Which one of the following physical quantities has a non-zero value at the instant the ball changes direction, right? So the one that remains the same, remember, the pull of gravity, acceleration due to gravity remains the same there. So I'm going to go for option A, which is our acceleration. So if you can look at EK there, it does have velocity, right? So that V part from EK is equivalent to half mv squared, right? So here uh it ball changes direction, right? So there usually is the maximum height there, right? So our velocity is 0. Again, you can see here P is equivalent to mv, so it means there is 0. Then velocity also there, it makes height is going to be 0. So according to that, our only option there, the acceleration due to gravity, remains what constant. Then 11 reads, an object is thrown vertically upwards. So if we're throwing the object vertically upwards, we know as it goes upwards, what happens to its velocity? It decreases until it gets to a value of what? 0 at the maximum height. Then which one of the following regarding the object's velocity and acceleration at the highest point of its motion is correct? Then ignore the effects of air of friction, right? So it means here we know at maximum height, the velocity should be 0. So at maximum height, the velocity should be 0. Then automatically that gets rid of what? Option C, which is maximum. Then after that, now our acceleration is always going to be what? Downwards. So it means the one that actually matches both of them is going to be option D, like that. Okay. Then moving on to question number 12 reads, a ball is released from a height above the ground, right? So released, it means our VI there, which is your initial velocity, is equivalent to 0 meters per second. So from a height above the floor, then the ball falls vertically and bounces off the floor a number of times. Then after that, ignore the effects of friction and assume that the collision of the ball and the floor is elastic, right? So it's elastic, it means no energy is being lost there. Then take the point of release of the ball as the reference point there. So the point of release of the ball as the reference point, and downwards as the direction, downwards direction as being what? Positive there. So we should also take note of that. Then which one of the following is a correct representation of the position time graph for the motion of the ball, right? So you can see this one is more of a velocity time graph, and then this one is also out. Then now we're looking for option C and option D, right? So in terms of this here, we should also take note that downwards is positive, right? Then the ball falls and then bounces elastically and then returns to the same height. So according to this, our graph must show repeating parabolic what sections, right? So now if we can look at option C, so option C is going to be incorrect, but our correct option is going to be option D. So option C, it actually fails when on the reference point, right? So reference point, remember, is equivalent to the point of what? Of release, right? And then again here, we chose the direction, or they gave us a direction, a specific of saying here, downward is positive like that. So it means our C fails at that other part also because the direction of downwards is not considered as being what? A positive there. So our only option that is correct is going to be option D. Moving on to question 13 there. 13 reads a ball is thrown vertically upwards. A ball is thrown vertically upwards into the air. Ignore the effects of friction. Then the net force are acting on the ball when the ball is at its highest point is there in terms of this, right? So you should know that whenever you throw an object there, always acceleration due to gravity is pulling this object way downwards, right? So in terms of this, the only force that is acting there is going to be our FG, right? So only force acting is the mg, FG, or remember I can say mg or I can say the what's the weight there. So velocity is equivalent to zero and does not mean a force is equivalent to zero. Always take note that whenever your velocity is zero at maximum height, it does not mean that the force is also going to be what? To be zero. So our only option here is option B, which reads here equal to the weight of the ball, right? Equal to the weight of the ball. Then moving on to question 14, which reads the statement below describe the motion of objects. So a feather falls from a certain height inside a vacuum, then a box slides along a smooth horizontal surface at a constant speed. A steel ball falls through the air in the absence of air friction. Which of the statements describe uniformly accelerated motion, right? So we're looking for uniformly accelerated motion, right? So according to this here, our A, option one, feather in a vacuum from a certain height inside a vacuum tube is correct. Then a box slides along a smooth horizontal surface at a constant speed. This one, no, because here this one is equivalent to what? To zero. So remember constant speed there. What are we having? If we're constant speed there, it means we're maintaining. So if we're maintaining our speed there, it means our acceleration is equivalent to what? To zero. Because according to this, our acceleration is equivalent to is the rate of change of what? Of velocity. So that V there, if it's constant, it means your acceleration is going to what? To be zero. So that one now becomes incorrect. Then option three reads a steel ball falls through the air in the absence of what? Of air friction, which is also what? Equal there, correct there. Why? Because here, free fall without air resistance gives us what? Our acceleration due to gravity. So our acceleration also there for that one is going to be what? To be G. So it means our correct options there is 1 and 3. So 1 and 3 only. So that's our option B there. Then moving on to the next question. Question 15 reads, which one of the graph below correctly represents the relationship between kinetic energy, which is your EK, of a free falling object and its speed V, right? So I'm going to start maybe with the formula there. Remember, our EK is equivalent to half mv squared, right? So now it means here kinetic energy is proportional to the square of what? Of velocity. Kinetic energy is proportional to the square of velocity or speed there, right? So the curved graph opening upwards starting from zero. That's what we're looking for. We're looking for a curved graph starting from a point of what? Of zero. So if we are to look at these options, our options that is correct is going to be option C. Then moving on to question 16, it says a ball is projected vertically upwards from a height x above the ground. After some time, the ball falls to the ground and bounces back to the same height from which it was projected, right? So it returns to the same height there, right? Then ignore the friction and assume that where there is negligible time lapse during the collision of the ball with the ground, which one of the following is the correct position time graph for the motion of the ball as described above, right? So now in terms of this, we're going to say it starts a height, okay, just to highlight there, it starts from a height x above the ground, right? So if you can see here, option B starts somewhere there, which is below. And then option A there, it starts there at X is fine. Then C also starts from there, right? So now in terms of this one is also going to be incorrect there because it doesn't accommodate our time properly there. Therefore, it means here in terms of this 16, it should start from a height X there, right? a height X. Like for example, there, our option D there, this one for C, you can see it starts below X there. Then after that, falls to the ground, right? Then after falling to the ground, bounces back to the same height, right? Where it started there. So it bounces to the same height. And then after that, we know our shape represents what? Repeats actually what is symmetrically. So it means our option D is the one that is correct there. Then question 17 raised there. An object is thrown vertically upwards from the ground. Which one of the following is correct regarding the direction of the acceleration of the object as it moves upwards and then downwards? Ignore the effects of air resistance, right? Uh, Whenever we're moving upwards, we should know that our acceleration is going to go where? Downwards, right? So our acceleration there is going to be moving where? Downwards, like that, right? So it means here we have eliminated option B and D, right? So also moving downwards, even if you're moving downwards, your acceleration is still going to go where? Downwards, right? So according to this, the only one that matches all these is going to be option C. Object is moving upwards, your acceleration is going to be downwards. Object is moving downwards, your acceleration due to gravity is also going to go where? Downwards there. Then moving on to question 18, it reads there, a ball is projected vertically upwards from the ground. It returns to the ground, makes an elastic collision, right? So there is no energy that is lost there with the ground and then bounces to the maximum height again. Then ignore the air resistance. Which one of the following velocity time graph correctly describes the motion of the ball? So according to this, the object bounces elastically and returns to elastic collision with the ground and then bounces to the maximum height, right? So you can see here in terms of this, there is an elastic collision there because here what happens there, it means now it bounced back to that set with the same what? A velocity there. It means our option A is going to be correct. But for C there, you can see there is a change in velocity there in terms of this one. Again, here you can see this part there, they're no longer the same as from here to there. So it means your velocity is going to be a different what? A negative value compared to the one at B there. And then the same applies with option what? Option D there. It falls under the same what? A category there. So our only correct option there is going to be our option A. Then moving on to question number 19, it reads there, an object falls freely in a vacuum near the surface of the earth. Which one of the following statements regarding the motion of the object is correct? Then an object falls freely in a vacuum near the surface of the earth. Which one of the following statements regarding the motion of the object is correct, right? So we should know that our acceleration is going to be what? To be constant. That's number one. So the rate of change of velocity is also going to be constant, right? So if we were to go to these options, the velocity of the object will remain constant. The rate of change of velocity is the one that is constant, right? Then A is incorrect. Then moving on to B, the velocity of the object will decrease uniformly. Also, this one is going to be incorrect. Then C, the rate of change of velocity of the object will increase, doesn't increase. Then option D says the rate of change of velocity remains what? Constant there. So it means our option, correct option is going to be option what? D there. Then moving on to the last question, 20. A stone is projected vertically upwards from the top of a building at a speed of v meters per second, right? So this is our initial velocity. The position time graph there below represents the motion of the stone. Ignore the effects of what? Air resistance, right? So which one of the combination below regarding the magnitude of the stone's velocity and acceleration at time t1 is correct, right? So we know at time t1 there, this is the max height above the ground, right? So we know that at max height there, our velocity is equivalent to what? To 0 meters per second, right? So now in terms of this, they're saying the magnitude of the velocity there is 0, therefore it's 0, 0. Then option C and D are automatically eliminated, right? Then after that, we also now know that the acceleration due to gravity will always be in 9,8 way downwards, right? So it means A there, 9,8. So the correct option is A. Okay, with that being said, thank you for watching.